Hello everyone. Welcome to the one of the integral sessions we have here in our OLake Community Week. This is gonna be the session that's one of the integral ones, and at the same time coming ahead and dropping at the end of our OLake Community Week. So it's gonna be very integral one. As you guys would be aware, the catalog environment and everything is changing rapidly, and that's the reason why 2025 and its recent updates are gonna be discussed by Arsham. And as stated, he's going to be comparing Glue, Polaris, LakeKeeper, all of those big names in the market, and how you're going to be going ahead and adopting them if the need be. For that, he's going to be covering with the demos. So stay tuned for that. So before we start off, let me give a quick introduction to our speaker over here. Arsham, he is the co-founder at Greybeam, and his company and his idea is pretty stoked. I've been following him for some time, and also we saw his Apache Iceberg Summit happened in 2025. He spoke about catalogs there, and that's the reason we and our company at OLake thought of bringing him in to our session and speak about catalogs yet again, but at the same time pretty informational. So we're going to be covering off and we're going to be starting off soon. And so I'm going to be the moderator of the session, guys. I'm going to be moderating all of your questions. I'm the Devril here at OLake. We look forward of having more such cool sessions. And lastly, we had one around ClickHouse. So OLake, if you guys are recently joining, is the fastest data replication tool. It helps to shift off your data from your traditional sources all the way to Apache Iceberg that's being rapidly adopted. But more on that would be catching on later. So let's start off with the session. And now the stage is yours, Arsham. Let me stop my screen.
Let's get into it. So Iceberg catalogs are a really interesting topic for me, just because we're kind of past the point of the file format wars. There was a period where there was a couple different competing open source table file formats, and we can kind of say now that Iceberg has won. I think even the founders of Iceberg don't like to say this, but it's looking like it. We've got an adoption by a bunch of the industry giants like Snowflake, Databricks, AWS. I don't think Iceberg's going to be going anywhere anytime soon. And yeah, I just want to warn you guys, during this conversation and presentation, I'm going to be saying the word catalog hundreds of times. So apologies, you're going to get used to it. But anyway, let's get started. Yeah, I'm actually visiting San Francisco from Toronto. I'm a Toronto native. Live in San Francisco right now. And what a great place to be building in the space. So I work at a company called Greybeam. I'm one of the co-founders here. What Greybeam does is we help run your small Snowflake queries on DuckDB. We use Iceberg as our data layer to provide interop between these engines. And whenever we see queries that run on, let's say they're scanning less than 100 gigabytes of data or something that's considered small, they often end up running faster and cheaper on these lighter engines like DuckDB, and that's kind of what we help companies with. There's no need to do like a massive migration because we've actually reverse engineered the Snowflake API, so no migration is required. You can just use the Snowflake compatible tools directly. So let's get into it. Yeah, so I kind of want to talk a little bit about what data catalogs are entirely. I think the term is really ambiguous. I think people have been throwing around the term catalog for everything. Like, is it really where you register your schemas? Is it like a metadata store? Is it where you get your business context? It's not good. Like, in the data ecosystem, we're seeing a lot of the tools start to come together. And I want to see more of that in the data catalog space as well, instead of having it mean 20 different things. But yeah, more of that to come. So before we even talk about Iceberg, before we talk about catalogs, I do want to just kind of roll back and kind of get a sense of like why we even need these systems. How did we get here? Where did it start? To kind of think about that, we need to kind of talk about this graph here. It's actually really cool. So I usually have the guests guess what the y-axis is, but I'll just ruin the surprise for everyone. But this is essentially the amount of data being collected on the web. You can see that there were some massive spikes. We got the internet boom from the 1990s to the 2000s. We got a decent amount, and there was this massive spike again in around 2008. And that was when we essentially got mobile devices. And as soon as people got mobile devices, they were uploading things on social media. There's a bunch of user-generated content, which kind of 4x the growth in that decade. And kind of with this additional data, what did it cost? Massive data sets. Yeah. So, back in the day, pre-2000s, we were able to actually get by on traditional database systems, like your MySQL, your SQL servers, all that kind of stuff. You could get by because the data sets weren't actually that big back then. If you need to scale your database server, all you had to do really was to vertically scale. It's expensive, but it was doable. And then we kind of got to a point in the early 2000s where there was like a hard limit on storage and compute. Data was growing faster than we could upgrade and vertically scale database servers. So we started to get into this like middle area where we have like these massively parallel processing systems like Teradata or Netezza or Greenplum. These were like distributed models. They used multiple machines at the same time. They were all really proprietary. It wasn't something that companies could run on their own really easily. And they effectively worked on this model of like splitting your data into multiple different compute units and having each machine, manage its own load. And then finally, all of them respond back to like a master node. Super cool in concept, great idea, worked really well in the early 2000s until we got this beautiful algorithm out of Google, MapReduce. So I think Google, Yahoo, Facebook, some of the big companies that were using these massive data sets and had access to all this infrastructure and all this fun stuff had the time to actually think about, okay, what's the future of this landscape going to look like? And it was around, I think, 2004, 2003, when Google came out with their distributed file system, GFS, and then MapReduce shortly after. This was huge. This let us do a lot of things at scale really quickly. That was kind of the early 2000s. This is kind of what we were working with. MapReduce was big. Everyone was talking about MapReduce. And then we entered the Hadoop era. So again, really cool, early 2000s to about 2015, I'd say the Hadoop era was really big. This was kind of the start of like the big data space as we know it, or the term big data was kind of coined in this era. Hadoop was in 2006 or so, and the big piece that they contributed was their distributed storage solution. Again, it worked really well with MapReduce and had this like powerful resource orchestrator for everything. Hadoop kind of let a lot of people do this kind of big data processing, but it was really slow, it was really complex, but you didn't need to be a Google to kind of do this. Yeah, and I think a lot of people are interested in the in the logo of Hadoop. Why is it an elephant? And it was literally just after the creator Doug's. It was one of the inventors of Hadoop's, his son's like favorite toy elephant or something. So pretty cool. So Hadoop was great. We got this distributed file system. We could do this big data processing, which is awesome. But we didn't really have SQL. We didn't really have ways for analysts to go and write SQL, which was their favorite flavor, until we got Hive. Hive was 2 years after Hadoop, I think 2008 or so. And it was like I don't want to say the first, but it was a really prominent SQL engine on top of Hadoop. It introduced the Hive metastore. It introduced a lot of the things that kind of made these big data systems usable by analysts. It kind of became the de facto metadata store for a while, but it had its own limitations when it came to like read-only views, high latency, but people were able to use SQL, which was huge. And then later on in this kind of Hadoop era, we got better and better file formats. If you think about what the advancements were and what people were really interested in is like, how can we get better serialization? So we got two things here. We got Avro and Parquet. Avro came out first. Their big thing was like their compact binary serialization format, and it actually allowed you to better schema evolution. So essentially it allowed like you to still read your data, even if the schema changed, and it was really good for these write-heavy workloads. In the Hadoop and Hive era, if you had there was a lot of cases where you would change your schema and everything would break and you have to rebuild everything from scratch, which was just a massive nightmare. And then Parquet actually showed up in like 2013. Parquet is still like the de facto standard. Like a lot of people still use Parquet. It's everywhere. It's an iceberg. So Parquet's been around for a long time. And their big innovation was, instead of storing data row by row, which they still kind of do, they store it in column by column. And you only need to read the columns that you really need to access. And it provides some metadata for you to do predicate push down. So it was much better for analytical workloads where you're doing all these aggregations on columns. But great. Okay, so we are now in the lakehouse era. So this is a totally different world. We're talking about lakehouses. Lakehouse is all about like object storage. You know, that's where we're kind of throwing everything. No longer do companies need to set up their own like array of hard disk drives and kind of couple them together, put the Hadoop distributed file system on there. You can just use S3 or R2 or whatever, and you can have one of these big cloud data providers build this out for you, which is fantastic. There's even actually local versions of this, of like MinIO, that you could run on your local machine and test things out, which is fantastic. Then we saw like the birth of the, and this is fairly recent, we saw the birth of the open table formats, like Hootie, Delta Lake, Iceberg. And you know, again, this was huge because now you no longer need to be locked in to a proprietary vendor's way of storing data. You can actually store your data in one way. And because these open table formats revolve around this like open spec, you can do whatever you want with it at this point. You can write your own stuff to do, you know, fancy compaction or whatever you want. And it opens it up to multiple different query engines. You no longer need to use the, you know, the dedicated query engine that your proprietary provider gives you. You can use Daft or Trino or Spark or DuckDB or Snowflake or whatever is better for your workload, which is fantastic. It's great for us as consumers. Yeah. So this is huge. This is fantastic. Great place to be. And this is kind of the era we're living in, so we get to breathe and enjoy this. So I kind of want to talk a little bit about why Iceberg specifically. Like, why was this so popular? Like, what kind of happened? What kind of spurred this? Why did the creators even build this? So the creators were at Netflix. They were running things on Hadoop, on Hive. They were having a lot of the same problems with correctness, performance at scale, or even just having like the schema evolutions, breaking, corrupting data, and doing all this stuff that was horrendous. Hive tables didn't really have ACID transactions, so if you had concurrent writes, you could potentially corrupt things and ruin stuff, which was just horrendous. You had to go rebuild again. If you wanted to partition stuff, it was really painful. But yeah, all these kind of problems led to them like trying to build their own little hacks and whatnot, but it couldn't get them to the point where they needed to go. And the reason being is Netflix was running their Hive setup on object store. You know, they couldn't. I shouldn't say this for them, but they needed the scale that object stores give them. Whereas like setting up a bunch of physical disk and trying to scale that manually is very challenging. So they moved to object store, but Hive inherently wasn't really built for object store. Object store, as you guys know, has really high latency, which impacts directory listing operations, which is like a key part of figuring out what is in your data lake. So, you know, even if you want to rename stuff in object stores, there is no rename operation. What you're doing is really copying and then deleting. So doing that in an object store where you have millions of files is very expensive. Whereas in Hive, you could just rename the directory. It's a file system. It's tracked by a database, and you're done. You know, very good. Object stores also have this concept of eventual consistency. So if you write something and you need it immediately, but then you go list it, that file might not be available. If you deleted a file, again, because of eventual consistency, it might still show up for a little bit until you get eventual consistency. So this was really painful. There were some slow things, like even S3 has like a limit on like how many objects you can read at a time per call. I think it's like 1,000. And if you have a table that's millions and millions of files, you're in trouble. So, birth of Iceberg. Iceberg is, you know, object storage first. That's their primary backend for data storage. Okay, so love to talk a little bit about how Iceberg actually works. So we got kind of like 4 layers, I would say. We have a metadata file, which tracks, you know, our our current state and our past states. Every time we do a commit, as in like we're writing data, updating things, deleting things, anything that changes the state of the data, we're actually creating a new metadata file. This file actually keeps some interesting stats for us as well, like the schema of the table, the partition, the sort order, maybe, yeah, like I talked about the snapshot info as well. And what the metadata file does is it points to essentially a set of manifest lists. Manifest lists are lists of all manifest files in a snapshot. So think of your manifest list as like the head of the snapshot, really. But a snapshot can have multiple manifest lists. It gets confusing. I'm going to show a little diagram about how we would actually walk through updating these manually. I think it will help. And then after manifest lists, we have manifest files. These are references essentially to data files and delete files. They have some additional metadata that helps us skip things like row counts, partition values, column level things like mins and maxes, and kind of the state. Like, okay, in this manifest file, we added a delete or removed this. This already existed, so we have some idea of what's going on with our data. And then finally, there's the data files themselves and the delete files. This is actually the data in your table. There's a couple ways to do deletes. I don't know if I'm going to get into them specifically because I'm already burning up a lot of time before I get into the demo. So we'll kind of get into how this actually works step by step a little bit to maybe clear things up. Okay, so let's start with just like a blank S3 bucket. We got nothing. We want to just kind of create a table. The first thing we would do is actually write a metadata file. This, like I mentioned earlier, is all about the schema, the partition specs, all that kind of stuff, but that's it. We just have an initial metadata file, and that is all. As soon as we want to go and add data, we need to add all this. We need to add a second metadata file, which has a snapshot reference as S1 here. We need to create a manifest list. I spelled manifest wrong. That's hilarious. And then a manifest file, and then also the data file. So all these need to happen before we can actually get any data into our table. If I wanted to then go and add some more data, I would then need to make another metadata file. Oh, here I corrected the spelling. That's hilarious. So here I need to add another metadata file. And now I have two snapshots. I have the S1 from before. I bring that over. And I also have S2 now, which now points to two manifest lists, one to track the old data and one to track the new data. So this is a lot of stuff going on. I actually want to do a demo where I did this manually with Python, but it got so cumbersome that we'd be here for a while to just kind of walk through all these steps. And this is kind of where a catalog comes in. I think I'm gonna pause real quick to see if there's any burning questions in the chat real quick. If there's anything really specific to this, I will answer it right away, but most of these are about catalog stuff. Okay, very good. Okay, we'll get to that very soon. Good. Okay, so I guess I'll glance over this real quick. Why do we need a catalog? It's to manage all these files. We want to manage the transactions. We want to manage all that kind of stuff. We want to tell the query engine right away, this is the manifest file you want to use. These are like some files you can skip. They improve query performance. They're kind of the glue between your data that's living in Iceberg and object storage and your query engines. There's a couple different types of catalogs we should know about. There's service-based catalogs. They typically hold their data in a relational database like a Postgres or a MySQL or a SQLite. They have kind of the central approach to keep all the metadata in one spot and then serve it out from there. So whenever you connect with, let's say like a query engine, you connect to the service-based catalog, usually HTTP or REST or something like that. And then it'll tell your query engine, hey, go here, this is the file to use. And based off your query, these are the best ones to look at. Don't look at this, so on and so forth. Next are file-based catalogs. These are kind of interesting. These actually store the metadata of your Iceberg table directly in the object store. So this is kind of like a decentralized approach. There's no like server you need to spin up or anything. The metadata is actually in the object layer. It's really simple. There's no like servers to set up or whatever. But there are some challenges with this in terms of like they're kind of harder to manage. You kind of have files sprawled everywhere. Tuning is kind of difficult. Like if you have high scale like workloads, like you're going to get a bit higher latency for this, but at least you don't have to manage another service. So there's some upside for this. I think if you have a smaller scale workload, this totally works. It's much simpler. It gets you off the ground to get started. Totally fine. Iceberg has one other kind of type of catalog. It's kind of a bit of both. There is a service component, and the metadata is kind of in object store as well. It's still centralized via an API, and there's like a standard REST spec that's open source as part of the Iceberg spec that lets you access things. This is much better for high scale workloads. It's better for concurrent operations. This is kind of the standard. Everyone's moving towards this. Everyone who's building Iceberg catalog typically adopts the REST spec. I think the only time you don't want to deal with this is, again, if you have a really small workload, low traffic, and it doesn't justify the cost of having this extra service in place. We're mainly going to be looking at these REST-based catalogs. They're kind of the future. That's what everyone's been using. Yeah, great. Okay, so let's talk about Glue. Glue is really powerful. So really feature-rich. It was, I think, one of the first that actually implemented the REST, like a REST-like Iceberg catalog. I think before that was probably the folks at Tabular. Glue is built on top of Glue's metadata store. So it does a little bit of everything. The folks at Glue have done a really good job at making this. There are lots of features. If you want to do like, Glue jobs, like automating your ETL pipelines using PySpark or Scala or Python, you want to have crawlers to automatically detect new tables. If you want to use like, have some like no code UI, they have Data Brew, there's Elastic Views, there's ML Transform, there's so much in Glue. If you're already in AWS and you want a mature platform, Glue is actually a really good option. And it's actively being improved. They're very involved in the Iceberg community. Yeah, like I'm always really happy with using Glue. I think of it as like the master tool. It can do a little bit of everything. I do want to show you guys a quick demo of setting up Glue. The pieces you guys need, what it's like to maybe do like a select or like an insert. We'll jump into it. So, all right, let me see if I can bring this over. Okay, great. So, cool. So I'm gonna share this repository with everyone after. Maybe I'll share with the OLake folks, and they can kind of post it somewhere. There will be a QR code at the end of this presentation where you guys can just access this right away if you guys are eager. I think there's still some things I got to clean up, but it will do the job. In terms of base requirements to get started for all these catalogs, I'm actually going to be using S3 as my object store. So you definitely need an AWS account. You need an S3 bucket, and you need some sort of S3 credentials. At least you need an access key and a secret for the access key. Some of the tools will require a role that has access to the S3 bucket as well. I've kind of set these up ahead of time, so we're not watching me do that. That's not really related to the Iceberg part of things. So let's kind of get started. I've kind of built a couple different modules for us to look at, but let's talk about Glue first. So, that's funny. Let's change this to Glue. Great. Okay, so setup. Other than the base setup, there's actually nothing you need. Glue is a managed service, so not much you need. Your user will kind of need one more permission. In AWS, you do need permission, or your role or your policy, or however you're going to provision this access. It does need access to the actual Glue service. So that's one extra thing you need to add, but there's no extra services or anything you need to download. All that kind of stuff is done for you. And in terms of bootstrapping, actually nothing you need to do. As soon as you set up your access key and your requirements, you're ready to start querying. Okay, so what I have here for us is a little Python module. I am using PyIceberg as my my write engine, my access engine, all that kind of stuff. It just makes everything a little bit easier for me to show in a single script. I have a little timer here that's going to give us some metrics in terms of like how things are progressing. And then I'll walk through the steps here that we're doing. I actually did the exact same steps for every single catalog so that we can kind of see the performance and the differences between them. Each one has a little bit of a different setup. I'm not going to get into how the load catalog function works because it is a little bit different for all of them, even though we're using REST catalogs in some places. Glue actually has its own special type of connection in Apache Iceberg, which is great. It actually helps out with a lot of things, and we're taking advantage of that here. So first thing we're doing is we're loading the catalog. This is just kind of creating the Python object. After that, we're creating a namespace. You can think of namespaces as kind of like a database, like the actual schema of the database. There is no concept of, I guess, databases in Glue. There kind of is a higher level thing, but there's no like database schema table. There's just a higher level grouping and then just the tables, and that's about it. And that the higher level grouping is like the namespace, and then below that is our table. So first operation we're doing is we're creating the namespace if it doesn't exist called webinar namespace. We are then listing our namespaces to make sure we successfully completed that operation. Next, I'm reading this Parquet file. Yellow taxi. Everyone knows. So this is the trip data set. I'm loading it in a data frame. This is a PyArrow data frame. If you guys aren't familiar with Arrow, it's a great format for transferring data over the network. It's columnar, so really good. There's no need to kind of switch between row and column-based formats in flight, which is great. So yeah, we're listing the namespace. We read the table into a data frame. We are creating a table if it doesn't exist. So in that namespace, webinar namespace, I'm creating something called webinar table. I pass in the schema from the data frame object, and then I'm giving it a location to throw it in, okay? After that, I just list the tables to make sure they're there. And then we actually do a lookup. So this actually happens quite often in your data frame or any really like Iceberg workflows. This lookup is essentially me taking a look at where the metadata lives and kind of getting a sense of how to access this table when I need to query it. This essentially is, if I go back here, the step where, we'll show this. It's a step where the catalog tells me, hey, use this metadata file, and these are like the subsequent pieces. I don't know. I don't think it actually pulls out the subsequent pieces. It just tells me, hey, snapshot 2 is the current snapshot that we're going to use today. All right, let's go back here. Great, so that's that operation. And then finally, we're doing an override. I think this is not required. So this override, we could do append as well. Override is just a way for me to rewrite the whole database table. In this case, this is a brand new table. There's nothing there, so this will just be like an append operation. And then finally, we are doing a little query. It's a very simple query. I'm doing a full scan, which is essentially the same as like just seeing what is there. And then I'm getting the length to see like how many how many rows we have. So why don't we run this? Before I run it, I will show what's in our S3 bucket here. So we have a little bucket called OLake Webinar. Let me refresh it, make sure we got nothing in here. I've been signed out. That's great. Awesome. Okay, cool. We got nothing here. Let's run this. Great. Run Python. Let's do glue right. Awesome. Okay, we're getting some more print outputs. After the print output, I believe we're reading the data frame, making the table. So sending the schema up to glue. And then we should be doing the override now. I know we're doing the override because it's saying, oh, this delete operation didn't match any records because there was nothing in the table already. Shouldn't take too long. Oh, very good. Okay, we got some numbers. Great. All right, real quick. Just the last print out here was, we wrote about, 3 million rows. Not too bad. Time-wise, just to load the catalog, that's about 200 milliseconds. Creating the namespace, so that's like the database or the organization layer, that's about 300 milliseconds. Listing namespaces, 87. Reading the local Parquet file, fairly fast. I'm on a NVMe SSD, so pretty quick to read that. It's not a huge file, it's like 50 megs, so even that, it's loading into memory, converting to PyArrow format, all that fun stuff. Creating the table, this feels quite a bit. 9 seconds to create the table with the schema. Again, I'm not loading any data. All I'm doing is actually setting up this. I'm just here at this point. I've just created the metadata file with the schema, and that's it. Finally, we're listing the tables just to see we did it. I believe it was there. We got the webinar table, and then we are loading the table. So 2 seconds for the catalog to tell me, hey, this is the current metadata file. And then finally, we are writing to the table. Took about 15 and a half seconds. At that point, what is Glue doing for us? It is creating all of this. It's creating the second metadata file, the list, the manifest file, and the data file itself. And then finally, to do a query at the end, where it takes about 4 seconds. To see what this looks like in S3 now, if I refresh, I now have a Glue directory. I have our database. I have our table directory. And now we actually have our Iceberg files. They're organized in kind of 2 subsets. We got the metadata files themselves, which is the metadata JSON. We got 2 of them. If you look at the time, one of them was at 37:14. And then the second one was about 20 seconds later. So perfect. That's exactly what we're expecting. And we got 2 arrow files. So one of them will be the manifest list, and one of them will be the manifest file. So you can tell based off of the M0 at the end which one is like the child. And then in terms of the data, we got 1 Parquet file, 50 megs. That's it. Cool. So again, we'll compare time between a couple of the other catalogs, but consider like the setup time was essentially nothing. We got this quick script, and we have an Iceberg table that's ready to query out of the box, really, really fast. And we had all the tools that Glue gives us, which is fantastic. I'm a big fan of Glue. We actually started using it as well, and when we started Greybeam, it was great. And again, yeah, you got the weight of Amazon behind you, so no joke. Okay, let's move on to one of the newer, let's say, yeah, one of the newer catalogs, Polaris. So this is an Apache incubating project. I think it's still incubating. They actually got their V1 release recently. Like I think it was in May or April they launched it, which is fantastic. We're really good to see more catalogs in the space. Lots of contributions from the Snowflake team and the Nessie team. So Nessie is another catalog. So they kind of joined forces to kind of make Polaris. The coolest thing about Polaris is how advanced its security model is. It's just out of this world how specific and comprehensive like the RBAC controls are, both in terms of like roles, but also principles and privileges and all this kind of stuff. There's a whole lot you can do. And it's not like you can't do that in AWS with Glue. It just takes a few more steps, whereas Polaris, it's right in your face. You can't do anything without it. They even have this cool concept called realms, which is like another way to give you isolation of these security policies and all that kind of stuff. And I believe they recently have support for Delta Lake, which is awesome. If I were to compare Polaris to something in terms of a screwdriver or something like that, it's probably the most fancy. It's got all these really cool security features to keep you nice and tight. So let's go look at the Polaris demo. This one is definitely a bit more involved. Let me clear my Glue setup. So I'll run Python glue clear. If you guys are interested in the clearing side, clearing doesn't actually delete the data. So like these timestamps are really fast. We're not actually deleting anything. We're just dropping the references in Glue. But let's continue. Let's go to Polaris. Okay, for those of you that have a keen eye, you probably see a lot of these steps here. So yeah, buckle in. All right, so for Polaris, definitely a lot more requirements. I am running this locally. This is not a managed service. You need to know a little bit about Git. You gotta have Docker. You gotta potentially, depending on which way you want to download and build it, you might need Java. You need JQ. All these kind of things. To download, you have a couple options. You could use the repo directly. Then you can build from source using Gradle. It's a Java project. Or you can use some of their Docker Compose files. They actually have a bunch of different examples. The Quick Start actually ships with 2 query engines. It comes with Trino and Spark, which is great. And they have a couple other options to give you, like, again, security, all the extra features you need for authentication. To bootstrap, it's a little bit involved. So first, we got to start up Polaris. And if you want to use it with S3, the example Docker Compose file is missing some things. You do need to make some changes there. I will make a note in the repo when I pull it up, but definitely need to do a little bit of dev work to kind of get this going. I've created a little script that does it for me. But essentially, it's a combination of 3 different Docker files that kind of use a Postgres backend to kind of get things going. But let's kind of get that going. Let's see if we can get this going. So we're doing Polaris start. Okay, we got a bunch of services. All right, let's see if the demo gods are with us today. Okay, we got some things healthy. Very good, that looks good. Let's start the rest of the steps. Okay, I think Polaris is up. Let's go take a look. Hurrah. If I do Docker PS, I should expect, we got Trino, we got Polaris. Very good. Okay, we're in a good spot. So next part of bootstrapping, we need to create a catalog. So Polaris, the Polaris catalog can actually have multiple catalogs in it. So it's a service that can hold multiple different catalogs. Another way for you to subset your Iceberg data sets. Again, all about security and letting you do extensible things. I have another script for this. It uses some Polaris commands, but essentially it's, hey, here's some secret, create a catalog, give it some name. I think I'm going to change the name just so I don't run into any interesting issues. Clearly, I've done this a couple times, so we'll call it Quick Start Catalog 4. And is there anything else I needed to update? I don't think so. We're storing things in S3. We have to give it some default storage location, and Polaris does want to roll ARN. It is not playing around. Okay, let's run this. So Polaris, create catalog. All right. Very good. Okay. Wow, we're two for 2 so far. That is great. Okay, so we have our catalog now. Next step, we got our catalog. We need to create a principal and a role. Again, very security focused. You got to have all these things set up. If you guys are from the Snowflake world, some of these things are probably starting to click. How they kind of decided to make these decisions, who they're kind of targeting in terms of their user base and all that kind of stuff. So, all right, we got a script here called create principal. Let's go take a look at it before we run it real quick. So a bunch of stuff there that doesn't matter. We're creating a principal called Quick Start User. Principals are essentially users. We're creating a role, and we're finally creating this like catalog role as well. Like there's principal roles and catalog roles. Yeah, you can do a lot with this. Okay, great. When I create a principal, it actually spits out a client ID and a client secret. I will need this to act as this new principal that I've created. So I'm going to put this in my environment file. Very good. We'll save that. Let's keep going. All right, Polaris, what you got next for us? So we're saving these credentials for later, and then now we got to grant the principal the role. Yeah, a lot of little steps to kind of get this going. But this is necessary complexity to do the things that we want to do with Polaris. All right, so the role is added now. We can take a look at that real quick. Again, we already looked at this one. I think the privilege one is last. And this essentially gives us finally the privilege to do things with the catalog. So all these things you need to do. I'm sure there's ways to do this a little bit faster in a production environment, or maybe even slower if you want to do it in a production environment. But you essentially need to set up this kind of scaffolding to kind of get things going. But at this point now, everything seems to have gone successful. We can kind of try to run the same things that we did with Glue. Let's go have a look. Okay, here is our Polaris write. Again, I'm using Apache Iceberg. The load catalog, you'll probably notice, is a little bit different. We do give it a scope. The credentials are a little bit different. Yeah, all these catalogs are a little bit different, even though they follow the REST spec. Yeah, but all the same operations. So nothing different there. We can just run this. Run Python Polaris write. Cool. Okay. We got that same error saying, hey, there's no data in this table. And that's for the overwrite step. So yeah, we're overwriting a table that there's nothing in it, but it's fine. We're going to append as well. Okay, there we go. Some results. We got the same row count, which is great, running the same data. But look at these query times. This is fantastic. Like loading the catalog, 75 milliseconds. Creating the namespace, 43 milliseconds. Listing, very fast. Reading the local, it's the same, no difference. Creating a table, under a second. That's awesome. Loading the table, 200 milliseconds. Really good. And then writing the table, roughly the same, seems to be a little bit better. Counting rows, roughly the same, seems to be a little bit better. But when we're going to be doing a lot of these operations, like the loading table, creating tables, things like that, like this is a significant improvement. And like that's something we can really be happy for. Like the total runtime for the Glue setup, I believe, was 30 seconds. Let's see if we have it. Oh, we're running out of room. Oh, we just got it. Very nice. 32 seconds. So again, big improvements for loading table, big improvements for creating table. That's awesome. And if we go look in S3, let's go back here. Oh, there we go. We got our Polaris. We have our webinar namespace. We have our webinar table. We have metadata. We have the same two metadata files. One was about 10 seconds after the first one. We got the two Avro files again, which are our manifest files and the manifest list. And then data-wise, same 50 megabytes. Fantastic. Great. So Polaris, very good. Very happy with it. And then last, I want to talk about LakeKeeper. So LakeKeeper, built in Rust, very light, very fast, Kubernetes native, which is fantastic. Like when I show you guys the setup, it's going to be really impressive what they've done. And they actually have this special feature, which I really like, which is kind of like this change events and approval. Whenever you change your schema, LakeKeeper notifies people downstream to tell them, hey, look, like something's changed. Like, do you want to approve this? If not, it pushes the work back. I'm kind of running out of time, so I don't want to spend too much time on this, but think of like data contracts. They've kind of built data contracts directly into the catalog, which is fantastic. Recently, they got some Trino support, which is great, and they've been big players in the Iceberg community and fantastic when it comes to support. I like to think of them as like a drill. They go really fast. They get things done. Let's do a quick demo for them as well. Let me see. Okay, let's continue. So, all right, let's look at our friend LakeKeeper. Very good. So for LakeKeeper setup, just need Docker. You could build this from scratch if you're interested. They did build LakeKeeper to be extensible. If you know a bit of Rust, you can do whatever you want with it, which is great. Fully open source, do what you need. In terms of downloading, you have a couple options. You can use their Docker Compose package, which is great. They have a couple examples, things with auth, security, even even a Trino query engine, which is useful. If you're right on Kubernetes, they have a Helm chart available, and they're actually working on their own community-driven operator as well, like a Kubernetes operator. If you're a binary guy, they got a binary. If you want to build, you can build. Lots of options, which is great. In terms of bootstrapping, it's fairly simple. Let's get it started. So Docker compose up, LakeKeeper, very nice. It seems like I already had it from before. Okay. Come on. Uh-oh. Driver failed. Okay. We have Polaris up, and it's not happy. So let's take Polaris down. And let's try again. Very good. Okay. So LakeKeeper has been very kind and actually provides us with a GUI. This is a welcome addition. So there's a couple ways to get the process started. You start LakeKeeper, obviously the service itself. They have a REST API you could use for those that want to do things programmatically, or you can use their UI. UI is nice and easy. And then right after that, you're ready to query. In the UI, all you need to do is create a warehouse. A warehouse is kind of like a reference to an S3 bucket. Let's create one right now. So we'll call it LakeKeeper warehouse. Okay, we're going to use S3. They have support for all these different formats. We are going to use an access key for our auth. I think I have one here I can pull. If you guys want to try to use this access key, you feel free to try. I will not be committing this to the GitHub repo, and I don't think it's going to be active for much longer after this, but feel free to catch me beforehand. Our bucket region is US West 2. The bucket name is OLake webinar, and the prefix we're going to call LakeKeeper. Very nice. The rest of the stuff I actually don't really need. I think we can go from here. Very nice. We have our warehouse, LakeKeeper warehouse. Inside here, we have number table 0. There's not much going on, but we are ready to go. We're fully bootstrapped, and we can run our Python script. So one thing I got to do is update this environment variable. We're calling it LakeKeeper warehouse now. And let's open up our write file. Same setup as we're used to. We got the same load catalog. A little bit different again for LakeKeeper. And let's run it. So we don't want to do Polaris LakeKeeper. We want to do the write, please. Okay. Oh no. Live demos. Look at this. We got AWS chunked encoding error. I'm actually not surprised. So I actually got this error earlier. I think there is some issue with the Apache Iceberg library that's trying to do some weird things with the AWS credentials that LakeKeeper passes back. Like a lot of these catalogs actually provide you with the credentials. Like I'm not providing credentials here at all. I'm just giving it access to the catalog. So there is some incompatibility there. I think usually it does work, but keep in mind Apache Iceberg is actually not even a V1 yet. LakeKeeper is not even a V1 yet, but it shows a lot of promise. I think if I got this demo to work properly, it would actually be very competitive with Polaris. I don't want to say it's going to be faster or whatever, but from my previous testing, it's been very fast, and I've been very impressed. But we need to keep in mind that these tools are ever growing. A lot of this stuff is open source, and a lot of these things are not even in V1 just yet, which means there's lots of room for improvement. If I look at our S3 bucket, though, let's go back here. Let's refresh this. So we did get it did do something. It did create a namespace, a table, and it created some metadata. This is the first metadata file. This is the initial one that we create. So this should have the schema. If I look in the LakeKeeper UI, let's refresh this. Look at that. I got a namespace, and I got a table, and I can see my schema. So great. I can even see that metadata file if I really want to. I can look at exactly what's going on there, the schema, the path to that, the current metadata file location, and all this fun stuff. So yeah, really promising. great to have a UI when you want to debug stuff. So very helpful. Thanks to the LakeKeeper folks. Keep up the good work. Great. So last thing I want to talk on, it's the last thing I'm going over. So I do want to stop real quick. So where are we heading? Lots of great open source catalogs coming out, a great signal of things to come. I love these new features everyone's coming out with. Things that we're slowly seeing is more governance, contracts, like LakeKeeper folks, and even other catalogs being kind of bundled together. The Data Hub folks, last time I spoke, were just a business catalog, but they have an Iceberg catalog built into it now too. It hit its 1.0 version back in March. So this is fantastic. Atlan even joined the party, and they were a Polaris catalog like launch partner. So I would love to see a place where all those different catalog terms come together, and we got one place. We can learn about our data, we can access our data, and so on and so forth. I think I'm going to stop there. I think this was a lot. If you guys have any questions, feel free to reach out to me on LinkedIn, or the source of the slides will be here. I think I'm going to stop there because I'm definitely over time, and I want to answer some questions in the chat. So thanks, everyone.
Hello. Yeah.
Hey.
Hi. Yeah, let me just fix it up. So thanks a lot, Arsham. Pretty insightful session so far, and I also pretty good to see the things off for in a session. Like I saw the summit and everything, but this time it was pretty good to see them in person, and the demo and everything worked pretty good. So we have a good set of questions. At the same time, I would like to go ahead and couple a bit of them together because there are a lot of them. Firstly, we have a very emerging question at the same time, very important one asked by Yasin. And she's asking, like, what are your insights if you need to choose between the following catalog tools for an on-prem lakehouse? Firstly, she's saying, is it Apache Hive Metastore, or Apache Polaris, or Nessie project, and then the LakeKeeper? So if you want to go ahead and talk about how organization will go ahead and adopt them at the same time, coupling the question with the Merlin. Merlin has also asked something in the same line. What are the organization looking up to?
Yeah. So if you're looking for on-prem, it actually does help you make the decision a little bit. You're kind of locked into some of these open source tools. You're not going to get these managed services. So really your choices are between like the LakeKeeper, the Polaris, the Nessie, things that you can kind of roll yourself. Which one would I pick is kind of depending on what the other objectives are. Like if I was in a larger enterprise, Polaris would actually look interesting to me when I need to do a lot of data governance things. That makes a lot of sense. If I'm at a smaller company where I want to move fast and I want to have like the founders support me, like LakeKeeper starts to make a lot of sense. If I want that snapshot support as like a first-class citizen, like I'm jumping between data sets all the time and I want to go from like, what was the data like today versus yesterday or a week ago, Nessie starts to make sense. But again, it really depends on what your use case is, what's most important to you, but you do have the advantage of just having to use an open source format because you're locked into on-prem. But if there's a more specific, maybe you can give me some more context, feel free to reach out to me on LinkedIn. I'm happy to chat and kind of weigh some of the options for you.
All right. So yeah, we might have a good quick another session on them. But yeah, like to answer your question, Yasin, I think it depends on a lot of parameters, but at the same time, moving on to the next one. So we have a question asked by Harish. That's also one of the good questions. He's asking, like, can we use Iceberg in Lakehouse Medallion architecture? And can we manage SCD too?
Sorry, Lakehouse managed architecture? I'd want to know exactly
Medallion.
Medallion architecture. Yeah, of course. Yeah, like I think you guys probably noticed the query times. So like there is some latency concerns that you might run into. So think of it as good for your bronze, silver, things like that. Fantastic. For your gold layer, where you're going to be querying it all the time, you might want to use something that's better for this like live analytics, things like ClickHouse or like maybe some fusion-based engine or something like that. But for the bronze and silver layer, fantastic. I would recommend it for sure. Yeah.
All right. So next question is actually pretty much linked to Greybeam as well. So we have Shubham asking, like, is there any plan to support querying Iceberg directly from Greybeam?
Hmm. Yeah, I think definitely like right now we leverage Iceberg as part of our platform to kind of provide query engines. So we are querying Iceberg directly. And it will be more and more a part of our roadmap. If you guys are interested in querying, getting access to query engines on top of Iceberg, we'd be a great tool for you guys to use.
Yeah, and I also say like with the Apache Iceberg and the adoption going on towards that, like over here in OLake, we go ahead and have a good talk around catalogs. So like we also promote REST catalogs and AWS Glue is also one of our offerings. So I think at the same time, it's definitely looking forward to see how the Apache Iceberg ecosystem is evolving and also supported by Greybeam. So we have a lot of questions, so gonna get you a bit hooked up on that. But yeah. So we have a question by Saurabh. He was also a speaker in one of our previous sessions, and he's asking like, how do catalog prevent lost updates with multiple writers? For example, like Spark, Flink, and hitting the same table. And also, do catalogs perform any special handling for object store eventual consistency? A pretty long one, but I think a pretty interesting one as well.
Yeah. I think each catalog does it a little bit differently, but they follow the Iceberg REST spec. So if you go dig up the Iceberg REST spec, depending on the version that you're using, it will do things a little bit differently, especially when it comes to deletes and updates. But think of it as like it will only make the new snapshot available once the full commit is done. Like that's the high level way to say it. But again, it really depends on what version of Iceberg table you're using and what that REST spec is like right now.
Okay. And then we have our next question. Let me go ahead and pump it up to the screen. So we have a guy and he's saying, considering my background and when dealing with kind of multi-engine access you have discussed, are there kind of any specific UI UX challenges? Hmm. I don't think it might revolve around much on our use case.
No, this is interesting. So there's definitely a huge UX pain in terms of like spinning up the different engines. Like that is actually painful. And getting them all to talk to the same catalog, even though they all speak the same REST spec, like you saw, even in my really basic setup where I was just using Iceberg, there was like minor differences for each one. And then once you have different engines on top of that, they all have their minor little differences about ways they want to talk to Iceberg. But as long as the engine supports the REST spec, you should be in a good spot. I obviously ran into that one issue today, but that's the gold standard. This query engine supports the REST spec. We should be in a good spot. In terms of UI challenges, this is more, I guess, back-end heavy stuff. So it's hard to say. It's really a UX problem right now. Like how can we get up all these engines? When to use the right one? That's a big part of what we deal with is like figuring out, okay, for this query, it scans this much data. Use this kind of engine or use that kind of engine. That's a big UX problem as well. Yeah.
All right. So I guess one of the last questions. We have Shubham asking of how mature is DuckDB support for Iceberg. And he's stating like there were issues around the support being not merged into the main DuckDB releases. They seem like promoting Duck Lake.
Yeah. This is a spicy topic for sure. I think everyone's kind of thinking the same thing. The Han is one of the founders of DuckDB definitely had this idea that maybe the Iceberg implementation is not the correct way to do things. And maybe you do need a metadata layer, like a Postgres or something that just tells you where things are. So that's why he made Duck Lake, and Duck Lake is really good. Like I don't have any bad things to say about it yet. It's very, very young, but they are committed, as per their roadmap, they are committed to continuing to support Iceberg and building out those features. We'll have to see what happens, but everyone's kind of thinking the same thing. Everyone's kind of worried about them releasing or building out their, I guess, their Iceberg support on DuckDB. And and we're hoping they still do it too. But yeah, with Duck Lake, it kind of changes the dynamic.
It's good to have a couple of spicy questions going around over here. But yeah, on that note, we have slowly approached the end of the session. So thanks a lot, Arsham. Let me go ahead and share my screen real quick. And yeah, so yeah. So, guys, we have approached to the end of the session, and there was a lot of engaging questions from you guys. I was following them along. Much more I was following on the demo, but I was also following up on the questions. So, pretty interesting ones came around. At the same time, if you guys have much more questions going around at the same, like Arsham is pretty active on LinkedIn, so you can go ahead and DM him over there, or you can just grab him a message. So he will be interested for that. But at the same time, we have our own community here at OLake. We would welcome you guys to go ahead and join us over Slack. So in the meantime, you can just scan these QR codes. It will drop you on our Slack. You can put our questions there. We have a lot of data engineers and everyone going around, and pump up those questions. Feel free to ask any kind of niche questions you have in your mind around basically this session or anything you might have. At the same time, GitHub has crossed the 1,000 stars. So yeah, but pretty good. The numbers been pretty great. We have a lot of people like Arsham and Saurabh and Shivji, our previous speakers, supporting us. So it was a good ride so far. A lot of contributors and everyone is supporting us. So feel free to join us. We have made some good considerable changes in our documentation, and we will looking forward for some new contributors. So catch us on the next side of that. And as stated, the questions and everything have been answered. But I have a personal question, Sham. Have you experimented with OLake, and what do you see the Apache Iceberg ecosystem going around with OLake? How do you like the tool, and at the same time, how do you think of it can be a good usage for the companies and fit in the organizations for the people? How do you think about that?
Yeah, really interesting. So I think one of the really powerful things that OLake has is it's like a really fast tool to get your data into Iceberg format, and you can deploy yourself. That's amazing. That's a huge win for everyone on the team. You guys have done some fantastic engineering work to make that happen. So this is amazing. Like, people are going to want to move their data to Iceberg format, and they're going to look for the best tools for it. And having such a powerful tool in OLake to move things quickly is amazing. We will very likely look at using OLake to kind of hydrate our data sets as well. So yeah, it's a wonderful addition to the open source ecosystem. I'm really, really happy to have you guys in the space.
All right. Thanks a lot. So, touching to the open source, guys, we would have been joining you guys more on such sessions, everything revolving around open source. And it's great to see companies like Greybeam and Arsham supporting us, the idea of OLake and everything going around. It would be great to host you again very soon and see you as one of the people who join us in the future sessions as well. Feel free to drop in your questions. Feel free to drop your spicy ones as well. We would welcome all of them along. So on that note, we would be going ahead and ending this event. So thanks a lot for your day, Arsham, and at the same time, the time you provided, especially in the morning. You look pretty fresh so far. I'm not the person who actually is the kind of person, but you are a good morning person. I see that. But on that note, we will be diving off. And thanks a lot, Arsham. See ya
Bye,
in our
folks. Thank
next future
you. Bye.
sessions. Bye bye.